Good morning. A friend of mine brought me a few interesting pieces to work on, so it's going to be a little longer before I get back to my own. Plus, I got a couple of rebuilds coming up. But anyway, it's been a while since I've made a video here, and I wanted to show you what we're going to be working on today. That's a Harman Kardon 930 twin power receiver. Now, I took a quick look at this. My friends had replaced some filter capacitors in it, and he says it was failing the dim bulb test, but I found with a larger bulb it was fine. And I took it off the dim bulb and I ran signal through both channels. And what I discovered was there's a serious imbalance between the left and right channel. So let's hook it up and take a look at it. I'll show you what I saw. Okay, so I've got it connected here, and I'm going to put some signal in and take a look at the outputs. This is left channel, right channel. You can see we've got 27 watts in the left channel, but only about 12 in the right. So, where do we start looking at this? Let's take a look. So the first question you need to ask yourself when you find a problem like this is, where do I start looking? Is the trouble in the preamp or the tone board or the power amp? And in an amplifier like this, it's pretty simple to determine that. All you need to do is remove the preamp out, main amp in jumpers, and just inject the signal straight into it and then look at your output. So that's what we're going to do. I'm going to pull the jumpers, and we're going to take our signal source and plug them straight into the amplifier. Now, let's see what we get. Okay, so let me put some signal in and see what we get here. That's directly into the output stage. You can see if you look at the power readings here that they're much closer. So our problem is going to be on the tone board or preamp section. I'm going to pull some schematics out and I'll show you where we start looking. Incidentally, before I start, I want to show you, for those of you who might say, well, that's great, Ray, but I don't have all that fancy test equipment that you have. Everybody should have a digital multimeter. It's just my go-to tool for when I get started on anything. And even though you have heard me say that meters may not be accurate at the frequencies we're looking at, we really don't care in this case. All we want to know is there a difference? Doesn't matter qualitative or quantitative level. We just want to know if there's a difference between channel A and channel B. And for that, we can just take a 1/4 inch, sorry, not a 1/4 inch, but an RCA jack, and plug it into each channel and just look at the outputs. So let me put some signal in. And we look at left channel preamp out. Our AC volts are 0.969. Right channel, 0.63. So coming out of the preamp, or the preamp jacks, we can see we have a serious imbalance. And you don't need all that test equipment to show that. A simple multimeter will show that you have an imbalance. Since both channels are being fed with 1 kilohertz, the meter, even if it's inaccurate at higher frequencies, will be inaccurate at the same level on both channels. So you can see this is about 2/3 of what the left channel is putting out. So next move is we want to take a look at our schematic. This is our power amp over here, and these are our main amp in, preamp out. And we saw that our preamp out shows a serious imbalance. We saw that on the multimeter, and I can show you on the scope. But basically, we're going to have to start going through this whole section here. Now, I'm going to check it at the outputs, I'm going to check it at the inputs. If we have an imbalance here, of course, there's nothing wrong. But I suspect this is where we're going to find our problem. And let's just take a look at the signal flow through here. Well, we know that this is our preamp out here. And that's coming through here. We also know that this is our left channel, and that's coming through here. So I'm going to just give you an idea what the signal flow is. Our input is coming through here, and you'll see we have our balance and volume controls right in this block here. And they are coming out, and I'm just going to do a quick and dirty here, like this. Our signal is going to go through here. Now, we may bypass everything, depending on the tone defeat switch, and go down through here, and around, and out through here. Really depends on the setting of that switch. So we may go through here, or alternatively, we may go through all this. So that's our basic signal flow. So I'm just going to check out and in, see where our loss is. And for that, I'm going to use the scope. It's a great visual tool, and I'll show you how I set it up so I can tell in a moment if I have an imbalance. Right now I have a signal fed in through the auxiliary channels, and I'm tapping it off going into the preamp board. Now this is before the volume or balance control, so the only way I can tell what channel I'm currently looking at is to take the jacks that I'm feeding the signal into out of the auxiliary. And when I pull the left, you can see my signal drops. Now I'm going to zoom in a little because I want you to take a good look at the scope. You should see that I have cursors here and here. Let me turn those up a little. And what that allows me to do is set my baseline. So I can see this is what my left channel is putting out. These cursors move. I can adjust them like this. So if I go to the right channel, you can see our signal going into the board is good. All the switches and pots have been cleaned. That's not the problem. We have an imbalance on the board. And we'll take another look at that board as we go through here. But basically, we have to test both channels to find where our imbalance is going. All right, so let's see what we need to look at. We have our first pair here, which is 501, 502. And the right channel, which is 551 and 552. Now, where are those guys on the board? I printed a board layout, and 501 and 502 are here and here. And if we look at the right-hand channel, we can see that 552 and 551 are here and here. So we have our left channel, right channel. And I believe that carries through when we go all the way through here and take a look. We need to find 503, 504, 553, 554. So 553, 554 are here. And then 504 and 503 are there. So we need to take a look and see where we're losing our signal at. So the first place I want to take a look is 502's collector and 552's collector. So let's see where we find those. 502's collector is going to be the center of this transistor. 552 collector of this transistor. Now I could go dual channel and put two probes in, but let's just do one, move from one to the other, just to give you a feel for what we're doing. Okay, so I'm looking at the collector of 502, which is the first pair of transistors on the left channel. Now you can see how out of focus this looks, but if we hit bandwidth limit on our scope, it takes all the noise out and cleans it up. Now that doesn't look like a perfect sine wave. We're not concerned about that. We're only concerned about what it looks like when it comes out. This is our left channel, and that's about what our amplitude is. So we want to look at the right channel and see what that looks like. Now don't laugh, I have my visor on because I don't want to short these transistors when I'm taking the scope probe in and out. And I like to see things as large as I can because I'm an old man. Okay. You can see our level has dropped appreciably right here. Don't worry about the jitter, that's just triggering. You can see when you look at our cursors that our loss is right there in the front. So we need to take a look at those transistors and, just as importantly, the electrolytic capacitors that are coupling our signals. So we're going to take a look at the schematic again. So here's our schematic. This one's a little larger and I haven't drawn on it yet. But we found the problem looking here and here. We already see our imbalance is pretty pronounced. So we're going to want to check from here to the input. Now there's not a lot there, but we have a capacitor here that we're going to want to take a look at, as well as our transistors and our capacitors here. So I'm going to pull these and check them out. We shouldn't really have to look at anything past here because remember, we're testing it here and here, and we already see a pronounced imbalance. Okay, so I went through and I checked the capacitors on the one channel that appeared to be weaker. It doesn't really look like that was the problem, but I did get to the root of it. So if you look, here's one channel, and here's the other. Now you see how equal they are? I am still in the preamp stage. Here's my probe, and I'm going between this transistor and this one, looking at the collectors. So let's look at the schematic. I verified that I had equal signal at the base of each of these transistors, which is important because just because we had it here does not necessarily mean we'll have it here. I've had cases in the past where one of these pots, be it the balance or the volume, has gone south. And what that'll cause is you'll have an imbalance you simply can't get rid of unless you can find a replacement pot. And that, on this equipment, is getting to be almost impossible. In any event, those check good because we had equal signal here and here. However, we did not have equal signal here and here. So I started looking at the weak channel, which I believe was our right. And I changed these capacitors here and here. And while I was at it, I just changed these because I want to get rid of all the variables, and we still had our imbalance. However, when I went back up to channel 1 and I changed out this, this, and this, as well as the input, even though again we know it was okay, that straightened our problem out. And it actually brought the gain down. Now, that's a little odd until you look closely at the circuit and see that you have this feedback path here. And this capacitor was the only one that tested bad. And when I say bad, take a look at this because this is really bad. You can see it has virtually no capacitance and the ESR is through the roof. I tested this with my Dayton DAT system. It's very handy for getting detailed looks at components, and all the other capacitors tested good. But now that I've changed this capacitor, everything in here looks good. So what I'm going to do now is I'm going to connect the output stage back up, and we'll look at the outputs and see if we have a good match. We should. All right, so now we got those capacitors all changed out. Let's see what we get here. You can see we have a much closer match in values left versus right channel. And there's always going to be a little bit of difference due to pot wear, component tolerance, but I can assure you that little bit of difference is completely inaudible. In fact, several watts is completely inaudible. So that's what our problem was. It wasn't where we thought it was, but this is the nature of troubleshooting. You give it your best analysis and sometimes you're wrong. But we did get to the root of the problem because it was in that one feedback capacitor. which as you saw was just terrible. Anyhow, I'm going to sign this video off now. I have a few more things to work on, and I'll be making some more hopefully over the next couple of days and getting them posted. As always, I hope you enjoyed watching this. I hope you learned something. I certainly had some lessons reinforced, and as always, I like giving back to the community that has given me so much. Thanks a lot, folks. Have a great day.